Hello everyone, today we are going to discuss question from JEE Advanced 2026 paper 2, which is from the solution chapter. It is saying two volatile liquids A and B forms an ideal solution. Consider 5 molar solution of B in A inside a closed container containing a total vapor pressure of 100 mm Hg at 300 Kelvin. The vapor pressure of the pure A at 300 Kelvin is 105 mm Hg. Assume that A and B behaves as an ideal gas in the vapor phase, and we have given us some values here. So how to do this question? Let us start. We have to answer these two questions on the basis of these descriptions, and how to do this. Let us start. First, what we have to do is we have to calculate the mole fraction. How to calculate the mole fractions? We have given a 5 molar solution of B in A. So if it is given 5 molar of B in A, that means if we have 5 molar means this 5 molar means 100. If we have 1000 gram of solvent, then it will have 5 mole of solvent. What is solvent? Here solvent is A, 5 mole of B. Now from here we can calculate mole fraction of A. So mole fraction of A will be equals to 1000 divided by the molar mass is given for the A, which is 1000 by 50 divided by 1000 by 50 plus 5 mole is given. So this will be equals to 20 by 20 plus 25 or 20 plus 5, which is equals to 0.8, and mole fraction of B will become 1 minus 0.8. This will be 0.2. We have both mole fraction, and these mole fractions are in the solution phase. That means that is chi A and chi B. So we have chi A and chi B. From this chi A and chi B, we know the Raoult's law and the Dalton's law of partial pressure. PT equals to chi A into PA naught plus chi B into PB naught. Now we know the PT as it is given. Total pressure is 100 mm Hg. We can put there 100, and chi A is 0.8, and PA naught is given 105, and XB is 0.2, and we don't know PB naught. We have to calculate this PB naught. So how can we calculate? PB naught will be equals to, this will become 0.8 into 105 will become 84 divided by 0.2. So this value will be 80 mm of Hg. That means the vapor pressure of B of the pure B will be 80 mm of Hg. So now we know the vapor pressure of pure A, pure B. Now we have to calculate the molar volume. So in the liquid phase, in the vapor phase, we have to calculate. We have to assume here it is written that we have to assume A and B behaves as an ideal gas in the vapor phase. So we will use the ideal gas equation, and from this molar volume will become RT by P, PV naught, molar volume of B if we are calculating. So this will be R can be taken as 0.08 liter ATM per mole per Kelvin. Temperature is given 300 Kelvin, and PB naught is 80. Because it is mm of Hg, we have to convert it into ATM. So now it will become 18 ATM. So when we calculate it, we will get 228 liter per mole. So this will be the molar volume of P in the vapor phase. So this is in vapor phase. You can say it is in vapor phase. Now when we have to calculate we know the molar volume of the B at the vapor phase. Now we have to calculate in the liquid phase. In liquid phase, how we can calculate? We know the density. We use the density. Here in this question, density is given as 0.5 gram per mole per hour. So now we know here that molar mass of gas B is 57. Molar mass, that means mass of 1 mole, 57 gram, and we know from the density 0.5 gram is equals to 1 ml. So 57 gram will be equals to 57 by 0.5, which is equals to 114 ml per mole. But this is in ml, so and this volume is the molar volume in the liquid phase of B. So now we have to calculate the ratio. In the 15th question it has been asked, we have to tell the molar volume of B in the vapor phase divided by molar volume of B in the liquid phase, and we have calculated both. In the vapor phase it will be 228,000 ml per mole, and in the liquid phase it will be 114 ml per mole. Now what we have to do, cancel out. If you cancel out these, we will get, this is the 2 times, so this will be 2000. So 2000 should be the correct answer. So the answer for this, it should be 15th question, should be 2000. And the other question is asking mole fraction of B in the vapor phase. What will be the mole fraction of B in the vapor phase? So we can calculate it easily. We know gamma B is the mole fraction of B in the vapor phase. We can calculate it as chi B into PB naught divided by PT. So chi B we have calculated is 0.2, and PB naught we know 80, and total pressure we know also 100. So when we cut this out, we will get 0.16. So 0.16 should be the mole fraction of B in the vapor phase. So 0.16 is the correct answer. Thank you so much for listening.